Good afternoon, everybody. Thank you so incredibly much for joining us for NERC's webinar about alternative recycling technologies. I'm Lynn Rubenstein. I'm the Executive Director of the Northeast Recycling Council. Before we get started, I'd like to thank our generous sponsors for the webinar that hopefully you see my slide. Our gold sponsor, the American Chemistry Council, and silver sponsors, Casella Resource Solutions and RRS. I want to be sure you know that the webinar is being recorded. A recording will be posted on the NERC website, and you will receive an email about that. It should be there by tomorrow morning, along with PowerPoint presentations. We want you to ask questions. To ask a question, you will be using the question box. To find the question box, note the little orange arrow, which is, well, I guess they reverse it, top right of your screen. You click on that and it opens the GoToWebinar dashboard. And you'll see in there questions. You open that, you type in your question and hit return. Craig, who will be our moderator, and I will be reading them as they come in, but we will then hold your questions until the end of all presentations, and then we'll be asking your questions. So we want them throughout. Don't hesitate. With that, we'll turn to the content you've been waiting for. I'm going to do the bios for all of our presenters and speakers, and then we'll get going with the content. So first, I'd like to introduce our webinar moderator, Craig Cookson. Craig is the Senior Director of Recycling and Recovery for the Plastics Division of the American Chemistry Council. He is responsible for leading the Plastic Division's strategic national initiatives to increase the recycling of plastics, advance opportunities for new recovery technologies, and promote awareness of plastics' role in providing sustainable solutions to society's greatest challenges. Before coming to ACC, he was the Vice President of Integrated Business Strategies at 720 Strategies, where he designed and implemented strategic grassroots programs for corporate, association, and nonprofit clients. Craig was also the Deputy Director of State-Federal Relations for Governor Mitt Romney. He holds a BA in Political Science, from the College of Holy Cross in Worcester, Massachusetts, and an MBA from Boston College in Massachusetts. Following a few words from Craig, not yet, we will hear from our three speakers, Paula Liu, Ron Cotterman, and Mark Aggerton. We'll hold questions, as I said, till the very end, but keep posting them. Paula is the Director at Closed Loop Partners, a hybrid investment innovation firm focused on the development of the circular economy. Her work focuses on evaluating new technologies, materials, and markets to drive investments towards viable, safe, and circular solutions, and to accelerate their commercialization. She currently leads the firm's research in advanced recycling. Paula received her MBA and MS from the University of Michigan and her BA from Cal Berkeley. Next, in his position as Vice President for Innovation and Sustainability, Ron Cotterman leads Sealed Air's efforts to develop and advance innovative packaging systems that enhance sustainability of products, processes, and services. He is responsible for front end of innovation opportunities that align with longer-term strategies and for delivering solutions to meet Sealed Air's 2025 sustainability pledge for 100% recyclability, reusability, and 50% recycled content. His overall goal is to solve customers' most critical packaging and sustainability challenges while bringing benefits to society. Ron has an undergraduate degree in chemical engineering from the University of Florida and a PhD in chemical engineering from UC Berkeley. And our final speaker is Mark Aggerton. Mark is a group scientist in Procter & Gamble's hair care packaging platform. His primary focus is creating a circular recycling solution by incorporating recycled resins from different technologies into our products. Mark's focus has a global footprint, looking for recycled resin opportunities in all of his brands. His education is both classical chemistry and mechanical engineering from the University of North Carolina, Charlotte, and the University of Cincinnati. Mark's worked in industry for 34 years, 26 of them have been at P&G. And with that, I'm going to turn to Craig Cookson, and after Craig, we'll be hearing from Paula. So thank you, everybody. Paul, let's see, Craig, You should speak, even though I don't hear you speaking.
There we go. Can you all hear me now? Great, thanks, Lynn. Thanks for the introduction. Appreciate being here today. As from my bio, you could tell that I am a native New Englander from the Northeast, born in Massachusetts, grew up in New Hampshire, lived in Massachusetts before coming to Washington, D.C. So always like being, having the opportunity to work with the folks from NERC. Appreciate again, Lynn Rubenstein and her leadership and the opportunity to be here with you today to talk about advanced recycling. So real quick, I work for the plastics division of the American Chemistry Council. Plastics are a really unique material in our modern life. They help us do more with less. We know that lightweight plastics help reduce the load when it comes to shipping and moving goods all throughout the country, really play a key role in keeping our food chain fresh and sanitary. And we know that food waste is one of the biggest contributors to greenhouse gas emissions. So really keeping food fresh and not wasting it is an important environmental benefit that plastics play. Unfortunately, though, we don't do a good enough job in recovering and recycling plastics after they've been used. And you know, we have mechanical recycling, which we'll hear about today, as well as sort of a newer term, advanced recycling, which we're going to talk about mainly today. They're both complementary. I think that's an important point that we need to stress before we get started. There are many different technologies, and we're going to hear about that today. There's not sort of one monolithic technology for advanced recycling, just as there isn't necessarily sometimes for mechanical. And there's different resins and other different products that can be produced based on the inputs as well as the process or technology used. So today we have three great presenters. We have Paula, of course, from an investment firm. We have a converter and also a brand company. And you're going to hear about some of the different technologies and key work streams that are going on in advanced recycling. So we look forward to your questions. As you're hearing the presentations and you're thinking of something, please submit a question as Lynn discussed in the question box. So with that said, I'm going to turn it over to Paula as our first presenter. Paula, you all set to go?
Yeah, can you hear me?
Yes.
Okay. Where does that prompt go? Sorry, I just have to share my screen. Can you see my screen?
We see your screen, but we don't see the, oh, getting very close. Now we just need it in slideshow and you'll be all set. Thank you, Paula.
Yeah.
Great, perfect.
Good afternoon, everyone. It's great to be here, and thanks to Lynn and Craig for helping to organize this webinar. As Craig mentioned, I am a director at Closed Loop Partners, which is a New York City-based investment firm and innovation center. And before we jump into today's presentation, or my presentation, just kind of wanted to provide a brief overview of all the main topics that we'll be covering today. I'll very briefly go over, our firm and our structure and how this plays into both advancing circular economy, but more specifically, our research around advanced recycling. Go over our strategies in creating a circular system for plastics, and then dive into some of our key research and findings from researching and lending within the sector over the last about 2.5 years. And then I'll close with our sort of viewpoint today on what's needed to succeed and scale advanced recycling in ways that are complementary to the mechanical market. So we are unique as an investment firm, having both sort of a fund management and innovation center embedded within our firm. Our unique structure as a venture capital, growth equity, project finance, and private equity kind of financiers allow us to provide capital to accelerate the growth of early stage companies as well as very mature, established, and successful companies. And then within the Center for the Circular Economy, which is our innovation center and where our advanced recycling research sits, we're able to help research, pilot, and test different business models, new materials, new technologies that allow us and our partners to de-risk new innovative solutions that are coming down the pike that will help bridge our linear systems to circular ones. So In 2018, the Center for Circular Economy and Closed Loop Partners launched the Advancing Circular Systems for Plastics initiative. As I mentioned, much like the center, the initiative is wholly focused on researching and testing and scaling different solutions that span reduction, reuse, mechanical recycling, and now advanced recycling. But our vision is really to create a waste-free future where all post-use plastics are reused or transformed into valuable building blocks in order to keep these resources within our economy and within the system for multiple generations and in perpetuity. And when we think about, all of the solutions that are needed to address the diversity of plastics, we're looking, beyond packaging. It is really important, and I think there are many great reasons why industry has been focusing on closing the loop and creating circular systems around packaging. But packaging really makes up just a small portion of all the plastics that are in our system. And so as we've developed this strategy for advancing circular systems for plastics and built an initiative around it, we're really focused on how to address the multiple forms and chemistries of plastic that exist in the system. That includes apparel, that includes electronics, which by weight are up to 20% plastic by weight. It includes specific industry plastic like construction or plastics from healthcare, as well as plastics that today are not economically viable to recycle through the mechanical system. So that could be bulky rigid plastics from automotive industry or lawn seats. Really, what we believe is that the biggest economic and environmental opportunity to create a circular system for plastics is keeping these materials at their highest value within our economy for as long as possible. And so kind of taking that holistic view of building a multi-pronged strategy, if you will, to address the diversity of plastic, Closed Loop Partners sort of our hierarchy of strategies to address plastic waste is what you see here on the screen. And unsurprising to maybe folks here on the webinar, it really does model or after the hierarchy of waste. But there are many ways in which we engage across these strategies. I've listed a couple here. The focus of today's presentation is really advanced recycling, but across these multiple strategies, Closed Loop Partners is through pre-competitive collaborations like Beyond the Bag or investments in companies like TemperPak, investing towards reduction or new material innovation around replacing plastics. We are invested in companies like Algramo, partnered with companies like Cup Club and Muse to pilot, test, and help understand how to better commercialize very nascent solutions like reuse and refill systems. We're invested in Amp Robotics and through our infrastructure fund, help to expand access to mechanical recycling programs across the U.S. and then in advanced recycling through our infrastructure fund as well. We have financed different technology companies across the U.S. and Canada, and as well as research the space. So really, when you think about these strategies, they are entirely complementary. What we have observed is doubling down on any one strategy is multiplying risk. And so from our perspective, all strategies are needed to address the diversity of plastics in our system. Okay, so on to the topic of advanced recycling. So in 2018, Closed Loop Partners launched our research in this space. And after looking at the landscape within the U.S. and Canada, we found that, and these are using 2018 numbers from IHS Markit, but only 6% of the overall demand for plastics is being met with recycled content today. And that percentage breaks down into, 1-2% when you're looking at specific resins. I think at the highest, we're meeting 19% of the demand for PET with recycled rPET. But as you look across the resins, that number goes down and down and down, all the way down to practically 0%. Concurrently, we have a growing demand, as I'm sure Ron is going to dive into the details of today, around CPG retailers wanting to replace their plastic packaging or introduce more recycled content into their plastic products and packaging. Using the Ellen MacArthur Foundation's new Plastics Economy Pact is just one example of how that demand is growing globally. They've noted that the demand between 2018 to 2025 is growing by over 500%. That degree of recycled content does not exist in the market, and as other research groups like RRS and NAPCOR have collaborated on and have also concluded, like us, there is a massive need to fill that supply gap, and we're going to have to scale or invest within our recycling systems, that's both mechanical systems and advanced recycling systems, and in new technologies in order to really unlock that supply. But advanced recycling, as Craig mentioned in our introduction and kickoff, is not a monolith. Just like the plastics in our system today, advanced recycling is an incredibly diverse field that is represented by multiple technology process concepts that include catalytic, that's another way of saying solvent-based processes, thermal processes, and biological processes. So as Closed Loop Partners defines advanced recycling, it is looking at a large swath of technology companies in the sector. In our first report that we released in what year are we in? In 2019, so 2 years ago now, we broke down the sort of the typology, so the classifications of technology processes into 3 buckets. So the first is conversion. Conversion processes use process concepts that are either solvent-based or thermal or a combination of both. Examples of these are pyrolysis and gasification. These technologies are producing refined hydrocarbons, fuels, and different petrochemicals as outputs to be used and in some cases, re-looped back into plastic supply chains. Specific outputs like naphtha, for example, can be recracked and made into new plastic. Decomposition technologies leverage solvent-based thermal or biological processes to break down the plastic polymer. Different specific types of decomposition technologies, there are many, but I've included 2 here, methanolysis, glycolysis, and enzymatic processes like companies like Carbios, where they're using enzymes to break down the plastics. In contrast, decomposition technologies are producing monomers and intermediaries, many of which, or I should say most of which, can be repolymerized into new plastics or moved into different supply chains, in different petrochemical supply chains. And then last but not least is purification technologies. These largely are solvent-based processes like dissolution, where the plastic polymer is purified, so color, smell within the plastic is removed. So Mark, who is speaking on this panel today, is very familiar and was part of the team involved in developing PureCycle, which is purification technology, which I'm sure you'll hear about more today. So in kind of a takeaway point from all of that is that the sector is incredibly diverse, but put together, purification, decomposition, and conversion technologies, which all take different kinds of feedstock, and we'll get into that in just a moment, really expand the scope of plastics that we will be able to recycle, repurpose, and loop back into our manufacturing processes. And the opportunity ahead for industry, for policymakers, for the plastics industry today is really figuring out how to do so in ways that are both environmentally friendly, that create value in the system, but there is certainly a business case to do so. I'll walk through a couple of key findings around the business case here. The first one is, again, coming from our 2019 report, Accelerating Circular Supply Chains for Plastic. When we looked at the US and Canadian market, we found that it was a $120 billion opportunity when you looked across the development of polymers, monomers, and petrochemicals. But we aren't the only ones who have found, interesting or financially positive kind of metrics around the possibility or potential of the sector. When Bloomberg's New Energy Finance put out their report, I believe it was at the end of 2019, they evaluated conversion and decomposition technologies and found that for different companies, IRRs floated between 11 to 33%, based on or depending on the different types of feedstock that these technology companies took. And in last fall, Closed Loop Partners, in partnership with ACC and Sealed Air, looked to better understand the volumes and flows of plastic within the US and Canada. In November, we launched a Tableau map, which is free to use and available on the Closed Loop Partners website. But we identified that 11.5 million metric tons of plastic packaging alone was ending up in landfill. So that means it translates into an 18% packaging recycling rate, and just tremendous opportunity to close the loop on this specific type of plastic packaging. Again, the sources of packaging or the sources of potential feedstock that align to the sector extend far beyond just packaging. I believe the NAPCOR report also found like 13.4 million metric tons or short tons of textiles that end up in landfill, much of which is synthetic fiber and could be feedstock for decomposition technologies that take that kind of material. And given the audience today, I thought I would spend also a little bit of time just helping break down sort of the feedstock specifications of different technology processes. So again, using sort of the perspective or the lens of breaking down the industry across technology types, conversion technologies tend to be have a lot more flexibility on the types of plastics that they can take. Decomposition and purification technologies, in contrast, require single sorted or single resin feedstocks. But it should be noted that in our research, kind of looking into over 100 technologies around the world over the last couple of years, and doing a deep dive on a dozen technologies in this last year, we have not come across a technology that is immune to any kind of pre-processing on the front end. The more targeted, I would say, there are strategic reasons for pre-processing on the front end from a feedstock perspective, because it really impacts the quality of the output for these technology companies. But conversion can take feedstock like shredded mixed films, mixed waste in the case of gasification technologies, and decomposition technologies are processing mixed colored PET or clean polypropylene and polystyrene. The degree of cleanliness and pre-processing that a particular company makes is really indicative of perhaps the capital expenditure that they've placed within their company on the pre-processing steps. So there are some companies that need a very clean regrind, and that kind of signals that they have limited pre-processing capacity within their facility. There are others that will purchase dirty film from Merck because they've made the CapEx investments in investing in technology or equipment that can help shred that or clean that to the degree that they need. But overall, and I think on this feedstock component, advanced recycling can and should complement mechanical markets. One of the key reasons of why we believe this is true is, first, from an environmental standpoint, comparing mechanical to any one of these processes, what we've observed is mechanical recycling uses significantly less energy than any of these processes, although the application of the output from each market is very different. And as I mentioned, advanced recycling can expand the scope of materials that we use and produce outputs that are of virgin-like quality outputs to be looped back into applications like food grade, for example. There are also systemic value creation potential for the conversion, decomposition, and purification technologies. Many of the companies that we have taken a deep dive on are paying for feedstock. That's almost universally true, or that is universally true for purification and decomposition technologies, and not always true for conversion. But whether it's a revenue opportunity by selling kind of residue from MRFs, or cost saving opportunity to divert from landfill, there is absolutely a systemic value potential here in scaling advanced recycling. Closed Loop Partners is taking a look to better create, or to create a finer point on what that value can look like, or which types of feedstock make most sense to create the highest value for mechanical markets. And that will come out in an investor roadmap that will be released later this year. And then there's also symbiotic kind of feedstock potential. I think the most interesting one that I'm seeing right now is around PET. But the fact that there are decomposition technologies that can take polyester fiber to increase the amount of rPET in the system ultimately also supports mechanical markets. But there are other examples of that, or like that in the system. So I'll quickly close with sort of 4 ideas of what needs to be true to ensure a circular future for plastics. We are conducting LCIAs on diverse processes right now, also going to be a part of the investor roadmap that comes out later this year. But we need clarity and collective consensus understanding around what those impacts are. We need to continue to collect data to better understand and define the role for advanced recycling in concert or in parallel to mechanical recycling markets. And we need to develop policy frameworks that both incentivize investment into the sector and the system, because this sector can and should rely on mechanical markets for sourcing and procurement. And finally, there's no shortage of collaboration and investment needed up and down the value chain and across industries to support the sector. I alluded to it, but we have an investor roadmap coming out in spring where we go over the technical and techno-economic analysis, the supply chain analysis, the LCAs, and the policy work. But if you take nothing from my conversation or my presentation today, just know that the technologies are tools at the end of the day. They do not determine circularity. It's really up to the stakeholders that want to develop these systems to ensure that we use these tools in ways that bridge our linear system to a circular one. So with that, I will pause or hand things over. Let's see. All right, thank you all.
Hey, thank you very much. And let's see, Lynn, can you make me the presenter? Okay, show my screen. So hopefully you're able to see my my first slide. Okay.
Yes, you're good.
My name is Ron Cotterman. I have a long history working in the flexible packaging area. I'm going to share with you some of the recent advances we've made in flexible packaging as it relates to a circular economy. But before I do so, I need to introduce you to Sealed Air. Sealed Air, some of you may know us, some may not. I'm going to talk to you from a converter perspective. Sealed Air is a packing solutions company. Our largest business is in the area of food packaging, but most of us know us for packaging on the e-commerce side. That actually started with a very iconic product, bubble wrap, which actually didn't even start as packaging. It started as wallpaper. So I'll give you a flavor of how that journey has evolved from wallpaper to packaging to circular economy. But we also have a medical packaging business. So as we think about recycling and circular economy, these type of materials, very thin, lightweight materials in highly regulated industries that have to comply with food law compliance, for example, or FDA as it relates to medical packaging, are very difficult to utilize recycled content and in some cases to recycle. But as a global company with approximately $5 billion in sales, operations across over 100 countries, we're dedicated to come up with global solutions that enable the circular economy. We put that in a pledge that came out in 2018, which we call our 2025 Sustainability and Plastics Pledge. Like many companies, we pledged that 100% of our products would be recyclable or reusable by 2025. But we took a very bold step on saying that we also are going to target 50% recycled content across all of our packaging by 2025. And we propose that we're going to do this by collaborating across our value chains and enabling these recycling circular loops to occur as well. But let me back up and tell you a little bit about what makes flexible packaging so special, so valuable, yet so difficult to recycle, and then what we're going to do about it. So I'm showing here some data that came from the Flexible Packaging Association. If you look at the US market for it, it's approximately $33.6 billion in sales. And you recall I told you that Sealed Air was about $5 billion. That's a global number, but we're a fairly large player in that flexible packaging industry. And if you look at what flexible packaging is used for across food and medical applications, they represent at least 3/4 of the applications that are out there. So again, applications that are going to be challenging to be able to use recycled content because of the regulations, and also, very importantly, the properties that are needed to service those market sectors. If we look at what packaging is made from that serves those sectors, again, here's some data from the Flexible Packaging Association that shows of the resin that's purchased to support this industry, nearly 87% of it is characterized as polyolefin, and that's predominantly polyethylene or to a lesser amount polypropylene. But there's a host of other materials that go along with those resins to give the packaging materials the properties that are needed to serve the medical, food, and even e-commerce industry. So consequently, you do have a fairly diverse range of polymer types that are used in flexible packaging, which is one of the reasons that makes it more difficult to recycle. The reason that those materials are used in the combinations they are because of the job that has to be done. That ultimately the primary role of packaging is to protect products. And recall I mentioned 3/4 of the applications for flexible packaging are in the food sector. That's a sector that you have to meet a range of application requirements, everything from the processor who's packing the product to the retailer or the food service company that's distributing it, and all the way to the consumer that have very high expectations of the quality and the safety and the convenience associated with purchasing those products. So the packaging has a lot of jobs to do as it goes across that value chain. But why is it so hard to recycle it though? So let me give you an example of packaging that might be used for meat, as an example, to extend the shelf life, or perhaps to help with the distribution of that meat. Or let's say that meat may even have bones or something in it. So Multiple layers are used to protect that product, as just shown schematically here. And each of those layers has a very specific function. In some cases, it might be to provide a barrier to the ingress of oxygen. In other cases, it might be puncture resistance. As I mentioned, if there might be sharp edges or a bone associated with packaging that product. Other cases, you want to market the product, so you have to have outside layers and even printing on that. And then you need layers to stick all of that together. What we've done as an industry is to evolve to a very, very sophisticated set of materials that are very, very lightweight and thin and contain all of these functions, where each layer has that specific function. A significant reduction in the total amount of materials if you were to make it out of a single material, for example. And furthermore, by using that small amount of packaging, you actually offset large amounts of damage or waste that occur across the supply chain. That's the value proposition of flexible packaging. But value propositions don't tell the whole story. I'm showing a chart that I call the conundrum of flexible packaging. Let's start on the right. If you want to look at it from a life cycle assessment, where you look at the contribution of packaging to the full life cycle associated with producing a food product, processing it, distributing it, cooking it, and even the waste, the packaging is a relatively small piece of that total. It's an insurance policy. Represents about 4% in the case of the US poultry supply chain. On the other hand, we conducted a Harris poll a number of years ago of US consumers, as we were trying to understand the impact of food waste on product purchasing decisions. And one of the questions that we asked is, which is more harmful to the environment, the packaging material or the amount of food that's discarded? And not surprisingly, the consumer perception was almost on a 10-to-1 ratio that the packaging material was more harmful to the environment than the food. Although from a life cycle assessment perspective, it's actually just the opposite. But nonetheless, we know that consumers buy products and choose based on packaging and not life cycle assessment specialists only. So we knew early on that we were going to have to focus on the end of life of the packaging material because of the perception that it has, and then that's only been augmented recently by the concerns over plastics in the environment. So when we talk about now what we have to do to move from the prior example, which is a very highly efficient material that had high performance advantages in terms of lightweighting, extending shelf life, distribution efficiency, to now what we need on the left-hand side of the life cycle, which is create demand for recycled content, create a means to recycle our product. We have to basically do both those jobs at once. It's not sufficient just to focus on the left-hand side of this to say that we have a circular material. We also have to recognize that we can't sacrifice the performance gains that we have of distributing food or medical supplies or even goods through our e-commerce supply chain. So consequently, now we have a bigger job. We not only have to continue to reduce our resource consumption, we have to be able to protect the product that's inside the package, but we also have to make sure that we can recycle it or reuse it after use, and that we can create a demand for recycled materials. So that's the job that we have to do now. What I'm going to describe to you, though, is a way that we have done that breaks it into two parts. The first part is what can we do that we can control relative to the material itself, those thin, lightweight materials. I call it the first half of the strategy, keeping that essential performance for protecting the product while helping to ensure the circularity of materials. So across our industry, and especially within Sealed Air, we're working very hard to take the complex structure that I showed you before and to simplify it as much as possible. We can't take it all the way to mono materials and still keep the performance, but we can make great strides in simplifying it. We can increase the use of materials that are more easily recyclable. We can also add functionality by increasing recycled content, and we're continuing to look at new innovative material technologies. These are things within the control of the flexible packaging industry that we're taking action on. What I'm showing here is an example of a cheese package, for example, where the cheese needs not only to have an extended shelf life, so there's a barrier layer associated with that package, but it also needs to be transparent to show the product and to carry product information along with it. So let's talk about the second half of the strategy. The second half is we have to work to advance the recycling technology along the lines of many of the things that Paula just mentioned to us. We need an expanded infrastructure if we're to collect, sort, and recycle and ultimately incorporate recycled materials back into new flexible packaging. A lot of the focus is on mechanical recycling. It's obviously the most common, obviously used for PET and high density. But for our business, we see that every time a material goes through mechanical recycling, it degrades the polymers somewhat. It consequently gets used in a lot of downcycled applications and often doesn't have the regulatory compliance to be used in things like food packaging for flexible packaging applications. On the other hand, we look at the advanced recycling. And advanced recycling, even though it's in the early stages of development, it takes those plastics, breaks them back down into the raw materials. It can be repolymerized back into new plastics. It can handle a broader variety of raw materials and mixed plastics. And the quality of the products that come out are identical to the virgin materials, and so can replace and offset the use of petroleum-based products. And furthermore, and probably most importantly for our business, is those materials then are compliant from a health and safety perspective for use in food and medical applications. So I'm going to focus on just one part of it, the conversion technologies that Paula talked about. And I'll talk very specifically just about pyrolysis, where you might take the waste plastic, put it into a reactor, pyrolysis reactor that would decompose it into an oil that subsequently can be treated at a refinery and put back into a steam cracker in place of something like naphtha. Once you get to that point, then that naphtha can be converted to ethylene, which can be repolymerized to new polyethylene, and the cycle continues. The only problem with this is while this works in theory, is that there's a very limited infrastructure for doing this. We have a broad infrastructure for mechanical recycling, but an infrastructure in advanced recycling that's in the early stages of development. So one of the solutions that Sealed Air brought to this is to help catalyze the development of that industry. So late last year, or in August of last year, we announced an investment that we were making in one of the leaders in that industry, Plastic Energy. Plastic Energy operates 2 facilities currently in Europe with plans to expand across other geographies and in Europe as well. But the other part of this that we were very interested in, beyond just helping the infrastructure develop, is a collaboration. Because we need to understand what we have to do on the film side to make sure that it can be fed as a feedstock into the advanced recycling side. So another part of this investment was very strategic, and it was strategic in the context of looking at what we have to do. Because another thing that we wanted out of this is we wanted to look at how we can actually create circular loops, not just recyclable materials. So in the fall last year, we also announced another milestone. We worked together with a large retailer in the UK, Tesco, that was accepting materials back from their customers of flexible plastics. Those flexible plastics were then collected and baled and transported to Plastic Energy, the pyrolysis company I mentioned, who then converted it into an oil, which was then taken by Sabic, a large petrochemical company, to make new plastic, which was used by Sealed Air to make a cheese packaging film, which was then used to package cheese by a company called Bradbury's that went back to Tesco. In other words, we closed the loop. We demonstrated that the supply chain can all work together to bring materials that historically had been difficult to collect or recycle or protect, perhaps even to reuse and recycle content, to have a true circular loop around materials. This project is really meant to be a demonstration of what's possible. It's at full commercial scale, but we hope to expand it well beyond just the products that are in this pilot and well beyond just packaging cheese. We think truly it's the next generation of what we need to be looking at, not only the next generation of recycling, not next generation of packaging, but also the next generation of recycling. And that we can see growth, which is really critical to companies to invest in this area, business growth as a result of these microcircular business models that can meet the goals of leading brands and retailers and give a real differentiated approach to the market. So let me now share with you kind of a little video, and if all works well, you'll get to see kind of how this all works. Okay, so just in conclusion, I want to thank you for your attention and also just give you some concluding thoughts. You know, plastic packaging, it does a lot for us in terms of very thin, lightweight materials to extend the shelf life, products such as cheese and meat and other products, safety and contamination prevention. But now what we're trying to do is get into the next new challenge that we have is creating a recyclable and a circular economy out of that material. And the answer of how you get all that done, though, is around innovation, which is one of the reasons that my title now is Vice President of Sustainability and Innovation, because innovation is what really makes that circular loop happen. So with that, I'd like to just conclude. Thank you for your attention and welcome comments at the end. Thank you.
Thanks, Ron. Lots of kudos on that adorable video. And Mark, you've been made the presenter. Hopefully you'll be able to show your screen and do all those things.
Working on it now. Hang on just a second. P&G likes to put lots of security systems on our thing.
So you feel really secure. Is that what you're telling me?
That's exactly. They feel that way. That's right. So it just popped up. I can't share your presentation. So let's see if it shows up here. I've given it the okay. And
if not, I can do it. And we can just advance. You tell me when to advance.
Okay. All right. Can you see it now?
Not yet. Sometimes there's a moment or two delay, but no, I do not see it. Are you showing your screen? You're sharing your screen?
Let me do it one more time. Just did, but let me try it again. It says it's showing.
It's lying to you.
Okay, why don't you pull it up and I'll just walk through with you then.
Okay.
Not waste a lot of time.
That's thanks. Let me just switch it around.
And I think, yep. Apologies to everyone for the issues with digital here. And as Lynn pulls my presentation up, thanks for having me today. As she mentioned earlier, I've been in the chemical engineering and mechanical engineering world for quite a while, and worked for Sandoz Chemicals in the petrochemical area for about 8 years before coming to P&G and working with soap. So quite a change from an engineer standpoint. Today, what I'd like to share is kind of how hair care, our products like Pantene, Herbal Essence, and Aussie, are really trying to create this circular entity. And so my presentation is slightly different. I'm going to give kind of a little storyline here. So this is typically done internally for my managers, trying to give them more information and some depth. So I typically start the presentation out with emphasis, this is how we see it internally to us. So really what needs to happen to see our goals get met, okay? So how do we get here, right? How do we get to all this pollution that we're seeing? You know, it's everywhere. You see it on the streets, it's on your TVs and stuff like that. So if we flash back a couple years, okay? I went back about, okay, Lynn? Thank you. I went back somewhere around 120 years and started kind of looking at our ability to pollute the planet. And you can see here I've got images from 1900, and you see about every 2 to 3 decades or so we run into a problem. And so here was 4 images that we picked in the timeline, and then the next slide brings us to today, where we're complaining about the oceans, and here we have a time now where COVID has come and hit us, and we have this severely contagious virus that's around us, and we're wearing these masks that then are somewhat polluted, and they're ending up everywhere. People are throwing them. So in a time that we are polluting so much and we're so concerned about it, we continue to pollute, which is kind of mind-boggling. Okay. And so what is that commonality amongst all of that, right? All the timelines, all of the images we see, the commonality is humans, and humans are just lazy, right? It's the path of least resistance. Nature's defined that many, many times for millennia. And so people will throw stuff down as opposed to walking an extra 10 feet and putting it in a recycle bin. That's part of the issue, is laziness. I've got a whole front yard. I live out kind of in the country, and I'm picking up everything all the time in my front yard. I know the kind of the people they are by what they're throwing out. I can see a whole spectrum of diapers to alcohol, right? But just laziness. But aside of that, right? So that's only one component of the issue that we have to deal with, right? In P&G, we have consumers that buy our products, and we want to make them happy, but we want to give them what they need. We have customers like the Tesco's and the Walmarts and the Costco's that buy our materials, and they have expectations for us. We have our competitors on the other side of the earth there that says we're going to do something, and we're going to make sure that we're leading the efforts. We have to kind of benchmark off of those. And of course, we have regulatory, which in my humble opinion, we have a lot of people often making decisions very quickly and rationally without understanding the full quality of the impact that that's going to make. Okay. So we really have 3 different stories going on here. We have to learn how to deal with our consumers, how do we deal with our customers, and then essentially what are we doing as a company as well as other companies, right? Each of them definitely have their own challenges. Each of them have a potential solution, but not them all unique. Okay. So our consumers, okay, that's the people buying our products. We're trying to make happy. They are heavily influenced by media. I mean, look at the state that the world is in today, bickering back and forth, not listening, speaking too much, right? For those that are old enough, remember back in the 1970s, one of those time periods that we lived that's very similar to what we're living today, where we had this Italian actor who would ride on the horseback and have a tear coming down his eyes, basically say, "Keep America beautiful." Big campaign, touched the hearts of lots of people, and I think for those that are old enough, remember it very vividly from the black and white TVs, I guess. Today we have Greta. For those that don't know Greta, she's a young autistic girl that has a lot of passion for this, and you can see the protests and things that are coming up using her kind of as the figurehead. So these expectations our consumers are really, and customers are real, right? And they flare up and they get really chaotic at times. And it's hard to tell, are we in a decade of, yes, this is important now, but it won't be for the next 2 decades, okay? And you see an influence there on those consumers by this example, right? If you've, again, those of old enough to remember in 1977, Time put out a magazine that says, you know, we got the ice age coming and we're going to freeze to death. We got to figure out how we're going to deal with all these temperature changes. And then 2006, they put another one out saying, you know, we're going to drown. We got to do something. The polar caps are melting. So the consumers are so confused. We've done that with our recycling system. We do it with our campaigns. We try to put labels on. We put labels on labels. We try to give instructions on it. We're running out of real estate on our packaging to do really everything we need. So we have to address the consumer somehow. Okay. And then we have our customer. Our customer, the big guys, they put you on the shelf so that you can display it in their areas, and you go ahead and advance them. And you know, if we're not following the trend of the consumer and what the media influence is, we get threats of they're going to de-shelf us, they're going to take our product off, they're going to move it to the floor area. So it's this constant fight about where we're going to be in the customer shelf. Let's go the other way, Lynn. One more. There we go. And so, you know, we see them as the consumer expects them to kind of lead, and by them leading, they put pressures on us, right? And you can see some of the examples of the pressures we get. You know, water is precious. If you look at shampoo in your shower, you know, it's not the shampoo that uses the majority of the water to get the job done. It's the person in the shower that's in there for 20 minutes using, you know, 60 gallons, you know, or 80 gallons in a shower. But you know, we'll take the brunt of it because we have the mechanism that has them that experience, all the way down to the innovative new forms and materials, right? So that's really good. You've seen some of that coming up with some of our products outside of hair, and you'll see some with hair here in the near future, seeing things like dry shampoos and things like that come out. So you will see these innovating forms. But from a packaging standpoint, you often start seeing combinations of those things. Plastic on the inside of fiberboard, which looks great. It could be recycled, typically isn't recycled. Another level of complexity we add to the system. Okay, next slide. Companies, and this brings us to these things, right? Everybody's seeing these Ambition 2030 goals, and they're all jumping on the bandwagon. The brands are doing it, you know, we want to accelerate it. We want to be, you know, benchmarking against our competitor, going faster to really push things, which really stresses the system more and doesn't always help. Okay. So this is the more common what you see, right? This is one of ours internally. You can find it on our websites, you know, 100% recyclable or reusable packages and a 50% or 50% reduction in virgin petroleum plastic packaging. So very interesting, right? And myself personally, I'm trying to change this metric. I believe it's the wrong one. I believe those are goals or milestones that you would do, but really our goal is to clean the environment up. And we have conditioners now that are in our tubes, and we've put material that is recyclable, but it doesn't get recycled. It goes directly to the landfill. So this whole thing about having 100% recyclable or reusable package, if it doesn't get back to a circularity, contributing back to a raw material, then this goal is meaningless to the environment. So my personal thing is we need to really start looking at what waste can we convert to do that. Okay, next slide. Example for those that are not aware, here's a little spectrum of the companies that are making some of the declarations of what they do. You see P&G's kind of out on the far right. And the reason is that is, you know, we're pretty anal retentive type A personality people here at P&G, all of us together. You won't find one that's not. And we all will constantly compete against each other just because that's what we do. But mainly when you look at that and take that personality and you start looking through the data, much like Paula had alluded to and Ron did, there's just not a mechanism to get us all the way there as fast as people are claiming. And the last thing the P&G wants to do is making claims but not being able to deliver on them. So if you often see us not signing an agreement or not completely putting our name on some paper, does not mean by any means that we are not fully supportive of these efforts. It just means that we may not be able to get there based on current infrastructures that we have today. Okay. So here's the problem. Everybody's already touched on it today. we got to get to this 50% reduction. Okay, let's go to the next one. So in this effort right now today, as soon as these things came out, not only my company, but other companies said, okay, I'll switch. I'll take plastic out of it. I'll go to aluminum. I'll start using steel. I'll use glass. Great things. It meets this criteria. It's one of those metrics I was mentioning. They get to check the box, but really they have terrible life cycle analysis when compared to plastic that Ron had kind of pointed out. Something like aluminum, like 4 times the amount of carbon dioxide generated in the process. Can't get recycled content, too rare. Doesn't come back to another bottle, and we're not sure the consumers will actually recycle that and refill it. So we've got all kind of studies going on internally with our consumers and launches you'll see in Europe coming up doing just those things. But by doing this, sometimes people react to getting to the goal very quickly, and by doing that, they're choosing solutions that will indeed reduce the plastic, but will create more environmental problems. Okay. Demand, everybody's touched on that. No reason to really sit on that one too more. That was a statement from Roberta from PepsiCo, just not enough. This is a great slide, and I think at the bottom, once you guys get this, there's where this came from. And this was put out in 2017, and the interesting thing was Geyer did this work where he went back to 1950, looked all the way to 2015, kind of surmised all of that plastic production waste and kind of stuff. Great paper. If you haven't seen it, should be noted on my document there. The interesting thing about this is look at the amount of material that's collected. 500 million metric tons are coming out, and it goes into its recycling system, and 100 million metric tons actually gets used a second time, which about 70% of that, I believe, goes to the fiber industry. But from an efficiency standpoint, we collected 400 million metric tons that we did nothing with except cycle it through a system, paying for it, and then dumping it or burning it. Kind of interesting. Okay, next slide. Another statement from the Intercept, right? You can pick and choose whatever you want to fit your agenda. Not trying to do that there. This is just another thing from the Intercept that's basically saying, look, we really haven't done a great job since we started making plastic. And a lot of the stuff was just being sent out of the US anyway to somebody else. So it's interesting that other people, depending on where your lean is, has a different perspective on it. Some pushing really hard to have some guilt there. Others like, well, just because we sent it off didn't mean it wasn't being recycled. Okay, next slide. I think the next one, yeah, going back to Geyer's paper again. Here's this cumulative plastic waste generation. He published his paper in 2017. The black line there really shows how we're going to grow over the next roughly 20 years or so. And the accumulation somewhere up around 13,000, 14,000 million metric tons of plastic waste generated. And if you look at the bottom right, the blue line is telling you how much we're going to recycle by the same time period. So there's a huge gap, even in the model of prediction. If you apply then the national sword, where we're now not even shipping stuff off and recycling it, the red line at the bottom and the one at the top are kind of reflecting that, or trying to reflect that we're recycling less than we were before, and we're going to have more accumulation than we did. Okay. So we're buried in plastic, but reality, we can't buy it. It seems like the weirdest thing in the world that we're polluting it so much and we're trying to buy it back and we just can't. Okay, next slide. And I think, as Ron touched on it, Paula touched on it, for materials that we bring back in, they have to meet certain criteria for not only our consumer, but for the FDA that we are regulated under by the cosmetics industry. So we have to use food grade materials. And if we choose not to use those materials, then we have to test our way and show the feedstock is stable and that there's no impurities. There's no anything called these SOIs that show these impurities are coming in. They also affect our manufacturing. As we push the PCR content up, we notice bottles don't perform as well in our fit for use testing. We notice our processing line actually has trouble. The reliability of the plant goes down, and the bottle really looks ugly. So that pushes us to look for the very high quality stuff. Well, when we start looking for that, right, we've already done the work in Europe. If everybody does what they're saying by 2025, there's only enough material to meet about 16% of the PET demand. My world kind of lives in the PET. We do some polyolefins for sure, and we do polypropylenes, but we're trying to drive that more to PET. because that's the most sought after. That's the most that the technologies really work the most with. HDP, even worse, right? It's harder to get, and a lot of the people that used HDP are moving back over to PET, the milk industry primarily, or the dairy industry, for some of the comments that Ron was making earlier about, you know, light protection, multiple layers, and doing things like that. So they're sold out. We're noticing our competitors are buying stock offtake up to 10 years in advance right now. Even some of those people taking the offtake, and if they can't use it all, they actually commoditize it and they sell it. So they're becoming a resin seller almost on their own if they can't use it all. Okay. So here's a solution, one solution, right? P&G really, in our world here, we lack influence. If I talk about hair for a moment, the amount of PET that I generate is less than 1% of the overall plastic production of PET, less than 1%. And so I'm a tiny blip on this thing, right? If you look at the reclaimers, the MRFs, the beverage industry, textiles, they are by far the biggest industry, and they actually create guidelines that try to filter and sort and get materials that are the best for them. And as I try to come in and say, well, I want my colored PET bag, they say, well, you know, it's not available because we sorted it out. Nobody wants it. And so you need to shift over to clear PET. Well, my customers, my consumers want beautiful bottles. The women have been very outspoken about it. They want both. They want something that's recyclable as well as beautiful in there. So this value stream that works today doesn't necessarily work for P&G in the hair context. It does in some other areas, and that's why I think the mechanical is something that we use today and will continue to use and support, but it's a value stream that it's not going to drive where I need to go. Okay. And if you look at that, it's all about money, right? It's about value. Companies have to stay in business, and completely understandable. But when you start to look at it here in these are North American numbers, you know, we're somewhere around the 10 to 20% being recovered, and that's including the polyesters and the polyolefins. When you look at that, the number on the bottom of the slide there for the fibers was 50% on this slide. I just saw something in December that said that's now moved to 70%. And the beverage industry, of course, they have their roughly 25% they're buying. So that's where everybody's kind of going because it sells. And what I'm proposing internally is the definition of recycle is to take something from the waste and convert it into something of value, right? And the infrastructure, the mechanical one's been there for many years, and we notice there's not a lot of influence of capital being induced into the system. So if you look at this data from the EPA from 1960, I went back and looked at all the years. The highest it ever got was about 30% recycling rate, and that was for all of it. That's including the papers also. But it really hasn't changed since 2000. And so really what I want to do is the next slide is, I guess it'll be the next one then. Yeah, we'll come back to it. So this was another one. So yeah, that one, this one here. So really what we're trying to do is create our own value stream, right? And I think Ron's kind of doing the same thing with their company, right? So there's a lot of material that nobody wants. So instead of trying to go in and upset an infrastructure that is not fully meeting the needs for the current system, understandably, but instead of us going and putting more pressure on that system, I think it's time to create a new system, right? And that's this advanced recycling. So if you go back to the other slide just for a second, Lynn, you know, if these are numbers that came out in December also, if you look at the amount of polyester collected in 2017, which was the last good number by the EPA, 330 million pounds, right? The beverage industry and the fabric industry has already said what they need for 2030, 3.4 million pounds. It doesn't assume any volume growth of either one of these industries, and it only assumes 25% recycled content in the fabric industry. So you can look at those numbers alone and say, we're way off, right? And we can try to invest as much capital as possible into the current infrastructure to make it stress even more, or we can make it more efficient doing what it does today and take those efforts and build it into this advanced recycling. And the example there, 13.4 billion pounds of fabrics were thrown away. And that could be a source for advanced recycling that Paula mentioned. It's one of the reasons we're trying to create a circular economy as opposed to a semi-circular economy. In the mechanical industry, if the fiber industry is buying up bottles very quickly, at 70% roughly, that means the bottle got one usage, maybe two. It then gets purchased by the fiber industry, and according to these numbers, it goes directly to the landfill. So that downcycling is not enabling, it's sequestering these materials in landfills that I don't think is good either. It means eventually we will build up our landfills until we don't have any ag space since population's growing, and we're just creating another problem. So downcycling, which seems to be a solution very quickly to many people because it gets reused once or twice, is really not. We're just pushing the problem down the road. Okay. And one more. Yep. So here's what we're trying to do, right? And we spent significant amount of time working with people, last slide, Lynn, trying to establish partnerships. And that partnership that we're doing now, we're about to sign some agreements with companies that, if you move up one, Lynn, in the deck, right there. So we're trying to, much like Paula and Ron alluded to already, we're trying to partner and collaborate. We're trying to create this value stream of waste plastic. And that waste plastic, again, trying to redefine it a little bit. If you look at a Coke bottle and it goes back into the system and it's picked out of there, that system was never waste then, right? Because it had a value. It's a commodity. It's being collected, it's being sorted, efforts and energy are being put into it. And so it was never really waste as it came back into the recycling facility. It's a value. And the colored PET is a waste. It goes in, it gets sorted out, and then goes directly to the landfill. And I'm trying to redefine that definition of recycle to say, let's take the waste, pull that out, create those field streams so the brand can work with there. We can then work with our MRFs and reclaimers to help with curbside collection, help with the municipalities to help keep those functioning, help with potential upgrades, help with potential business models or mechanical engineering if we need to put resources against it. You just saw something with the recycling partnership where they started a polypropylene council consortia here, I think right in December, where they awarded financial gifts to 4 people across the nation, and they're now going from recycling of all these materials were trash before. Now all of a sudden, within 1 month or 2 months, they are now a value stream. So the same thing can be done with these other waste. So we're at the stage now, we're reaching out. We've done all of our homework with looking at MRFs and reclaimers in around West Virginia and around Tennessee, where we're going to start our initial big operations in advanced chemical recycling, where we will then start engaging these to go after these low value PETs. As Paula mentioned, right, advanced recycling to us is all of them. You're going to see us use dissolution, which is our pure cycle of cleaning that material. We know it gets around 30, 35 cycles before that polymer can't be used again. We know mechanical, we've done the studies on this, it gets 1 to 3 cycles before it can't really be used anymore, starts discoloring and breaking down, carbonizing. So dissolution is one that we're using. Depolymerization is one we're looking. We're hoping to take the PET, the polyester, depolymerize it, take it back to a monomer form, and then rebuild it directly from that. So that circular economy, exactly like the other people we're talking today. So what we're really looking for today is sharing the information, what we're doing as a brand, trying to kick off this new infrastructure, pointing out that it takes 3 of us. It takes the consumer, the customer, and the companies. All of us are lazy because we're all humans, and we have to understand that, accept it, and actually, start making amends for that. An example that all of us on the call probably are good recyclers or try to be good recyclers or good stewards of that. But I would challenge to look in your bathrooms. Our studies show that somewhere, I don't know, less than 15% of the people will actually throw their shampoo bottles or other plastic bottles in the trash can in their bathroom, and then that goes directly to their trash can. It doesn't go to the recycle. So even to that level, we could use some help. So as you look through the presentation, you now know that I'm out looking at MRFs, I'm looking at reclaimers, I'm looking for low value PET, and I think there's partnerships there. We're looking to do things as easy as working with the NFL or the Olympics so that we can collect those materials, convert those back, whether it's through pyrolysis or depolymerization, so that will be something that starts that circular economy. So thanks for the time. Next slide has my contact information. If anybody would like to contact me, feel free to do so. I welcome the questions or comments, complaints, or criticisms. All are fine.
Thank you, Mark. I see that Craig is here. We've had a lot of extremely interesting questions come in. There's still time to post more, so feel free. Craig, you get to ask the great questions.
Yeah, I'll try to, I know, we have probably maybe 10 to 12, 14 minutes for questions. So I'd ask the panelists to be pithy in their comments, please. So I'll try to do my best to get to everything we can. I would just say really quick, and why don't we start with you, Paul, and then Ron. So between collection, sortation, pre-processing, the feedstock, lining up your downstream customers, the actual process itself, what do you think is the most challenging piece of this, right? I mean, this isn't sort of a one piece of the puzzle, right? There's 5, 6 parts of this that have to fit together. So I know, Paula, you sort of said that all of them, but give us a little bit of perspective of what you see as sort of the highest hurdle to overcome to really make this all work.
Yeah, from what we've looked into over the last year is it's really the collections component and getting it to a pre-processed level that aligns to where the technologies are capable of processing those materials. So I would, we need to collect more. We need to find new sources of material. Mark and I both mentioned polyester textiles as contributing to supply, but really unlocking that feedstock and aligning it to the specifications of the advanced recycling technologies.
Great. Ron?
I think I look at it from a timescale perspective. Right now, I think our most urgent need is getting projects underway, putting steel in the ground on infrastructure, because that's going to take years with permitting and the build out of that infrastructure. So, there's a great urgency to do that now, which is why we invested in that area to help catalyze, some of that work. Then the next big challenge is going to be reverse logistics for us. We need to be able to pull material back from various sources to feed that infrastructure. But I actually think that's going to be a shorter time frame, and it may not rely on conventional collection streams as we have today. I think you're seeing new companies starting to sprout up in that space. I'm not doing a commercial, but Agilex spun out their company called Cyclex, which then subsequently made a partnership with Exxon, and that's a logistics company in it. So I think that we have to look at the time scale, and infrastructure to me is what's needed. We need to get projects kicked off now. And as a member of the Alliance in Plastic Waste, I think that's also a priority for that organization as well, is to have catalytic capital basically to get these projects moving, so investors will come into this space and really help advanced recycling get a firm grip or a beachhold, I guess.
Thank you. Mark?
Yeah, I think you're going to see us come out fairly quickly. You've already seen an announcement in Europe last year where we partnered with Indorama and Ionica, polymerization stuff at lower concentrations. That's probably our first shots. You'll see something start again in 2022 that will be on the shelf using a mass balance approach. So we are already lining the projects up and making commitments. So you will, it's supporting Ron's statement. What we've chosen to do is go with the bigger players that already have the capital in today. The infrastructure is already built, and we'll utilize that while the other materials come on or the other plants come online. So for us, Ron hit on it. We've already looked at logistics. We understand the mileage. We know what we can kind of do there. Because we're using a mass balance approach, we have a lot more flexibility to take, more of kind of a mixed plastics into it. So you're seeing some of the stuff, some of the suppliers we're working with are just buying mixed bales and processing those. Some are buying carpet, but we're trying to push them to start using thermoforms and flakes and dust, everything else that's being utilized and going straight to the landfill. So we see it moving pretty fast, and it's probably just on bullheaded and pushing people a lot.
Great. So this question, just for Paula and Mark as well, kind of a clarifying question is, Paula, you had mentioned sort of, and this was quoted, sort of 6%, only 6% of plastic demand is met. So there was kind of a question around how is that determined? And then Mark, you kind of talked about it's very difficult to buy plastics, right? And so can you talk a little bit more about sort of the what you both meant by each of those comments as sort of clarifications for the audience?
Yeah, the 6% demand, well, it's analysis that I should caveat or note that IHS Markit was the team that helped us kind of run the market analysis in the first project. And demand by IHS and for that project was centered around the projected kind of use of that plastic through however they collect that information. But yeah, demand is greater than supply, but it's a demand metric as defined by IHS.
Great. Mark?
Yeah, and as Paula mentioned, right, they did a nice study and put out a report, I think in 2020, where they hit on this and broke all the polymers down by units, you know, and looked at it. We use the same number. I actually use Paula's report all the time, that 6% number, and 4.5% for polyolefins. Interesting thing, you know, with COVID, with the National Sword, we're seeing even less collection than we've seen in the past. So I actually then, after I saw Paula's data, I climbed into the EPA data again, and they do a pretty good job of separating it there. So there's multiple sources globally that are reflecting the same rough numbers of 6% for North America, a little bit higher in Europe, but for the most part, they're single digit or barely above double digit. And then the projections, the way they do that in the brands is they basically just say, what are we making today? What's our growth look like? And then just start amplifying the amount of resin that we're buying, right? So that's how we get to those inflated numbers.
Thank you. So turn the page here a little bit. I'm going to start with Ron this time. You know, there was a mention in the questions about that pyrolysis does not count as recycling in California, and so the policy landscape that's needed, sort of, right? I mean, oftentimes policy kind of lags innovation and technology. So, and obviously a very particular interest in policy for the American Chemistry Council. So Ron, talk to us a little bit about some of the policy drivers that you see that are important here. And then I'd like to go to Mark and then Paula as well.
Yeah, well, you know, I know this audience is predominantly you know, North American, but you know, we've been operating over in Europe where the policy questions are quite complex over there as well. I think clear definitions are required, but also removing obstacles like you highlighted. I think if there's some restrictions in California to advanced recycling, you know, we need to understand, you know, really the basis of that, and then you know, see if there's some alternative if recycling now is more important than the reason what those restrictions were put in the first place. But I think more so than policy, there's new procedures as well. We talk about mass balance because it's hard to track individual atoms or molecules through a recycling process. But mass balance, yeah, it involves a lot of trust, or it involves certification. And so as part of our project that we did with Tesco, we actually had to certify. We had to certify that, okay, so our incoming materials that would come from Savic, that they had a guaranteed percentage of recycled content. Then they had to come into our facility and audit and make sure that the packaging films that we produced had a guaranteed certified level of recycled content as per what we said. And that certification, in this case, it's an ISCC certification, but we're going to need to build trust as part of this as well. And so I think, you know, along with, you know, making sure that we've got a clear regulatory path, is making sure that we've got a clear path to, you know, to build confidence and trust in what we're trying to do, that it not only is what it says it is, but it's also good for the environment, that the carbon footprint and the impact is less than if we were taking petroleum out of the ground or landfilling or incinerating, you know, the materials. And I think we have to bring all that together. So it's regulatory is part of it, but it's not the only hurdle we've got to address.
Right. Great. Thank you, Mark.
Yeah, to touch on Ron's statement about Europe, we've been in several meetings with legislators there and lawyers there, and it's quite interesting, right? As they put new legislation out and they're making statements about no colored PET, no this, no that, that you're going to have to pay the fine. Some of the really weird things that are hanging things up is the fines that will be pushed off to the brands doesn't go back to the infrastructure to continue to build it. It goes back into the governmental pockets where, at least from my perspective, a lot of waste happens in the government, right? And so if that's the case, we're moving down the wrong path there by just saying, let's penalize everybody and then we're not going to do anything with the infrastructure. So I think that's entirely wrong. That's why I think it's hung up a little bit. I think the other thing that's happening for North America is that legislation is being modified slightly. So advanced recycling isn't characterized as a sanitation or, you know, a landfill type of approach like mechanical industry is today. So they're going to kind of go away into a different legislation, and we're working with some of the chemical companies now, talking to legislative people to have a brand perspective on it also. So I think those are changing. The one piece that I, as an individual, often have trouble with is hypocrisy, right? So you have typically people making rules and laws that aren't recycling, right? An example of California sometimes where they put all these things in there. They put bottle deposits, and then within a week they shut down 400 kiosk or bottle collection centers because they're running it in the negative because the people working there are making more money than what the bottles are worth. So the answer is to shut it down as opposed to look at the business model again, or to send all your stuff offshore and claim that your recycling numbers are a lot greater than they are. I think we have to put those elephants on the table and say, look, that's not good either, right? Sending your problem somewhere else, sequestering in the ground is not a good thing. We need to deal with these. Pyrolysis is a way to do it. Gasifications are ways to do it. They have to become slightly more efficient or more efficient. And then if you look at Asia, right, look at Japan, right? Japan doesn't allow mechanical recycling systems in cosmetics at all, zero. It's against the law. And they have like 8,000 pyrolysis units online running, right? So the solution for Japan is different from North America. And trying to create guidelines or acceptance policies that will just be one thing is not going to meet our global need.
Paula, on policy? Yeah, briefly, you know, I think policy can be a very catalytic tool for the system. When we look at markets like Europe, mandates for recycled content is largely driving a lot of the investment and project activity growth there. We do need to align policy to meet the objectives that we're trying to achieve, which I think is all to keep resources within our economy and in order to reduce kind of extraction. So from our perspective, and we're diving into like looking at product standards, looking at different EPR principles and other kind of mechanisms to try to understand what the highest impact policy measures and incentives can be. Ultimately, at the end of the day, all of those policies and incentives have to align to you know, the different actions that we want stakeholders to take and ensure circular kind of outcomes. So making sure that the processes are producing output that can maintain or that can stay in our system for as long as possible and incentivizing those pathways.
Great. Thanks, Paula. And just just sort of building real quick off something Ron said around mass balance is folks should check out the Ellen MacArthur Foundation's white paper that looks at sort of mass balance and the importance of that in context of advanced recycling and the connection to mass balance and helping renewable energy and sort of the tracking of other things like commodities as well. So I think we're kind of out of time, but I wanted to give, Lynn, if it's okay, if I can get everybody just a kind of a 15-second closing statement if there's anything they didn't get to say. I know we didn't really get to touch on environmental stuff, but why don't we quickly go, Paula, 15 seconds?
Sure. You know, we've been looking at both the economic and LCA or environmental kind of impacts of this sector, and in a couple of months we'll be releasing an investor roadmap that is a summation of that over a year-long research project. So if you go onto our website, there's a way for you to sign up for our newsletter to get updates on when that's out.
Thanks, Paul. Ron?
Circular economy, it's two words. I like the circularity because we're going to keep molecules moving in a circle, but the economy, it has to be efficient. It has to be low carbon. It has to make economic sense. So advanced recycling, I think, is the key that unopens the lock to circular economy.
And Mark?
I think my short statement would be advanced recycling is going to enable us to clean up our landfills and our beaches and our oceans, right? It's going to have more flexibility than anything that would exist today.
Great. Well, thank you, panel. You've been excellent and a lot of great information. I think your contact information was in there, so folks have follow-up questions, but I'll turn it back to Lynn for some closing remarks.
Great. And thank you, everybody. Just really fascinating information. As Craig noted, we didn't have time to touch on all of the questions. I think I'll probably send some out and you can elect whether to respond to them or not. But mostly, I want to thank all four of you. Tremendous job. And to recognize our sponsors, ACC, Casella Resources, and RRS. And to note that NERC has many more webinars coming up, including tomorrow. So you can find the complete list and registration links on the NERC homepage. The recording of this webinar and PDFs of the PowerPoint presentations will also be on the NERC homepage in the next few hours. And with that, again, I'll say thank you, everybody, and I guess I was told I can still say Happy New Year. So Happy New Year, and have a great balance of your day, everybody. Bye-bye.
Thanks, guys. Happy New Year.
Bye-bye.